Welcome to Computer and Network Security. Today we are going to talk about SNMP. So first of all, SNMP stands for the Simple Network Management Protocol. And what it allows us to do is it's a protocol that allows us to communicate with our different network devices so that we can figure out status and whether there's any problems with any of them, and possibly do a little bit of debugging as to any issues that may arise with our networking equipment, the hardware like the routers and the switches and gateways and so on that we have in our network. Especially in largely distributed networks, this becomes much more critical rather than a home network where you probably only have a wireless router plugged into a modem. And so if something is wrong with your home network, it's a lot easier to figure out just by resetting a couple devices and running a few diagnostic tests. When you call into customer service, though, if you have a problem with your home network, potentially they're going to be using SNMP so that they can communicate directly with your modem. And this is because they are administering a very, very largely distributed network, because they have customers that may be located all around the city, if not a state, or even larger depending on the provider. So they could utilize SNMP for being able to diagnose problems and see if it's an issue with your modem, with your line, or whether the issue is on your side inside of your own network, where you would have to diagnose it through your router or your switch, or how your computers are connected, possibly your computer itself needing to reboot. The easiest thing to do on our networks when something goes wrong is you reboot it. However, this is not always an option if you have a network where a lot of people are dependent on it. Think about a company where you have tens of thousands of users, or at a university where you have a lot of users that may all be filtering through a router. You don't necessarily want to just reboot that router at any point during the day, because it's going to drop all of the different connections, especially if they are NATed coming back in and your router is also acting as your network address translation server. So you have to be careful with that, and so SNMP gives us a way that we can try to diagnose problems, figure out what's going on with our hardware, and get status messages back from them periodically. If we don't get status messages from our hardware when we have it configured to, that also could be a notification to us that there might be a problem and that we need to just take a closer look at it. A network management system is just a collection of tools for network monitoring and control that's integrated with a single operator interface that has a powerful but a user-friendly set of commands for performing most or all network management tasks, and hopefully a minimal amount of separate equipment. Some network providers will provide you also with some hardware for SNMP, and you'll see how that communicates with everything here. I have a diagram coming up here in a couple slides where you see where that fits in. So the architecture for network management, we have a management station, a management agent, a management information base, and then the network management protocol, which is where SNMP fits in. So we have all of these four things have to be present in our network management architecture. To start off with, the management station. This is typically just a standalone device, serves as the interface for the human network manager into the network management system. This could be a separate piece of hardware where a network administrator would go over to something and connect directly with that. This could also just be a computer where we have a program, an interface on it, so that the network administrator is able to monitor everything that's going on in the network from his or her desktop. A management agent, this is going to respond to requests for information or actions from a management station and asynchronously provide the management station with important but unsolicited information. This is going to be your network device. So if your router or your switch or your gateway is going to act as part of this network management architecture, it's going to be a management agent, so that it's able to respond to these requests from the management station when it says, are you still alive? If it's just a ping message, just making sure that it's up, or how much data are you transmitting? How much data has gone through you in the last half hour, and so on. So this would be acting as a management agent. The management information base is just the collection of resources in the network. These are called objects. The management station performs monitoring by retrieving the value of these MIB objects. So on each one of these agents, there's going to be a collection of resources that are called the management information base, or the MIBs. These are the objects which are stored on the management agents that the management station can ping the agent, and then it's going to get an MIB back which will contain the data that it's looking at or looking for. And then the SNMP is typically the network management protocol that is used with network management architectures. SNMP was standardized originally in 1988. It's based on three different RFCs, 1155, 1213, and 1157. Structure and identification of management information for TCP/IP-based networks, management information base for network management TCP/IP-based internets. So this is where the MIBs are defined, and then SNMP is defined specifically in RFC 1157. So specifically with SNMP, it's an application layer protocol that's part of the TCP/IP protocol suite that operates over UDP. I know this seems a little ironic that we say that we're using TCP/IP, but we're operating over UDP. And I'm not quite sure if UDP/IP just didn't take off, but TCP/IP is the protocol suite that's used on the internet. And at layer 4, though, we can utilize layer 4 of the OSI model. We can utilize either TCP or UDP at that layer, and this is going to be connection-oriented versus connectionless. However, in the internet model, we utilize TCP/IP, even though we could use UDP or TCP for our connections. Management applications then will issue GET request, GET next request, and SET request SNMP messages, and then the agent responds with a GET response message. So here is the overview looking at the SNMP management station and the SNMP agent. So assume that the agent is something like a router, and the management station, assume this is just a program which is running on a specific computer. Like I said, it could be a separate hardware device that network administrators would go and log into, or be able to go that it's going to be on a server rack that has a monitor connected to it so that it's able to see this. Management stations can be very complicated or very simple. They could be complicated. They could send out text messages. They could send emails if something goes wrong. They could be running on a cron job so that they will automatically check all of these different agents at different times of the day, or maybe every 5 minutes, 10 minutes it pings it. Depending on your network traffic, your network load would depend on how frequently you want to do this. How much redundancy you have in your network may also be an issue. If you have a highly redundant network, then you might not need to check these devices as frequently, because if something fails, hopefully you have a failover to your redundant device. And so you don't necessarily need to check as frequently, but maybe just once an hour to see if something has gone wrong and that you need to fix your failover device or your fault-tolerant devices that you have set up in your network. So you can see that the management application sends out these different requests like GET request, GET next request, or SET request. Those are the three. It goes through the SNMP manager over UDP and IP, and then whatever network dependent protocols we have, whether we're using Ethernet or fiber down at that layer. It goes over the network or the internet. So this could be something which is outside of the network that's monitoring devices that are inside of the network. Obviously, you would have to have some kind of a path into the network to allow this to happen. Comes back up through on the right side in the agent, the network dependent protocols, up through IP, UDP, back to the SNMP agent now. So you can see that dotted line drawn that says SNMP messages between the SNMP manager and the SNMP agent. Whenever you see that dotted line drawn between two protocol stacks, that should tell you that those are actually communicating end to end rather than communicating point to point like we would have with IP or MAC or any of those network dependent protocols. So those are communicating end to end. We come back up from the SNMP agent. We send the GET request, GET next request, or SET request back up. We have our SNMP managed object, which is going to pull from the MIB and then return it with the GET response or a trap message, which is going to come back. It comes back through the network and back to our management application. The growth of SNMP is somewhat fascinating. It's grown very quickly. SNMP version 1 was very simple, just provide simple network management, easy to implement, easy to configure, but there were three main deficiencies with it. One is that there was a lack of support for distributed network management. With distributed network management, when you have very, very large networks and they're distributed over possibly different LANs, so that you're having to communicate over the internet, SNMP version 1 didn't have any security built into it, so it made it very difficult for you to have secure networks and still be able to monitor it with SNMP. There were some functional deficiencies and there were security deficiencies. There was no security built into SNMP version 1. So version 2 came out in 1993 and addressed the lack of support for distributed network management and functional deficiencies. And then SNMP version 3 came out in 1998, and that's where we finally put security into our SNMP. If you want some more information on SNMP, you can look at the papers that I have posted. You can look online. There are a lot of resources on SNMP and the different devices that support SNMP. You can even buy some home devices. Some of your home routers can support SNMP, and you can set it up on your own computer and monitor your own router. Probably not that necessary, as I explained towards the beginning of this lecture. However, it's kind of neat to play around with that you can get it working on your own home network, communicating with your own router using SNMP. The textbooks that we have for the class, one of the online chapters, chapter 13 of the textbook, has SNMP in it. It's kind of lengthy. It goes through a lot of details. I just try to give you a nice overview here of SNMP so that you can go dig into the nitty-gritty details on your own. If you have any questions, let me know. Good luck.